Welcome to the Transum Podcast, a monthly roundup of the new features on the transum.org website, providing mathematical puzzles, games, learning activities, and the ever-popular mathematics lesson starter of the day. Here's your host, John Tranter.
Hello and welcome to podcast number 101. Podcast 101. Sounds like an introductory course to podcasting. Anyway, it is the podcast for the month of April 2023. It's now the 1st of April, and I must say I'm exhausted. Not surprisingly, really, because I've just completed a 31-day march. Do you get it? 31? Yes. Okay. Right, let's begin, as normal, with the puzzle of the month. Cupcakes were being sold at 3 prices. Large cupcakes were £1 each, medium cupcakes were 2 for £1, and small cupcakes were 3 for £1. Some children, there were as many boys as girls, and 2 of the girls were twins. These children were given £7 to spend on these cupcakes, and each child received exactly the same types and number of cupcakes, and no cupcakes were cut up or divided, or no cupcakes were harmed in the making of this puzzle. Anyway, the question is, how many cupcakes did each receive, and how many children were there? So, rewind this podcast if you want to hear that again. I will give the answer next month, but please let me know if you have a nice, elegant solution, because, well, my solution is not really that elegant. So I'd love to hear from you if you can solve that problem. It's so annoying when April Fool's Day does not fall on a school day. It's on a Saturday this year. It robs the maths teacher of the opportunity to catch their students out with the 1 out of 10 lesson starter. This year I've added an old story lower down the page, which shows how a paradox is used as an April Fool's Day joke as well. So if you've never done this with a class, give them this. You have to insist on silence in the class while they do it, otherwise the joke doesn't work. But it gives you a little bit of fun, one up on the students. Just watch out if they try to get even, though. Anyway, Easter will be with us very soon, and most of you will have already broken up for the Easter holidays. It's not too late, however, to spread the excitement of the season with your pupils by sending them an activity from the Easter Maths collection. Now, I recommend Systematic Easter Eggs, which has 5 levels of challenge, and it's great to send by email for an Easter activity for your students. Thanks to Sarah Carter at Maths Equals Love for the permission she gave for her puzzles to be used as challenges on the Factor Trees page. They really are fun to do, and I've made it so that you can scribble on the diagram as you eliminate possibilities. So have a look at that. By the way, all the things I'm talking about, all these links, are in the newsletter, transum.org/newsletter. Or if you prefer, transum.org/newsletter, if you're a little bit more posh. Anyway, it's only just occurred to me how closely related the topics of parametric equations and composite functions are. Bit late to the party there. Anyway, there is a transum exercise for both concepts, and I've now linked them together. So from one you can easily get to the other. Transum subscriber Sharon had a request.
I wanted to give my Year 11s more practice of compound interest questions, where an amount is also added regularly. I also think this is important, as in real-life situations, we generally add amounts and not just leave an amount in a savings account.
Okay, good idea. So in response to this suggestion, there is now a level 6 for the compound interest exercise, and, well, have a go at that. Or give it to your students to have a go at. That might be even better. I have been slowly but surely adding topics to the advanced refreshing revision visual aid, I guess we could call it. I'm pleased to show you that there are quite a few topics to choose from. If you, I've put it in the newsletter, and obviously if you go to the page, you can see all the different topics that you can choose from. So they're all taken from the IB or A-level syllabus, or syllabi, as I'm talking about two of them. And basically you can choose which topics you want, and you get the panels appear, and you can make the starter for your lesson as long or as short as you wish, but it's great for retrieval practice, for reminding the students of the basics of some of the concepts in higher level maths.
You can find Transum Mathematics at www.transum.org.
I've also just updated the smallest number activity page. I really love this activity. To do at the end of term maybe. You give all the students a little bit of paper, about 2 centimetres by 5. Measurements aren't important. Just rip up some old recycled paper, give everybody a little tiny bit of paper, and they write on the paper their name and a number. The number has to be a positive integer. And the idea is that whoever has chosen the smallest number that nobody else has chosen is the winner. You could have a little daft prize, an Easter egg or something for this. So, on the page, on the Transum website, there's a little grid that you can collect in this piece of paper, one at a time, and in a sort of a dramatic fashion, unfurl them and write on the grid the names of the students that have chosen that number. So it can all be a lot of fun. Obviously the students, by the way, I should have said this earlier, have to keep their numbers to themselves, keep them secret as they're writing them down, and then scrunch their piece of paper up so nobody else can see. But then you write their names next to the number in a table. If there is more than one student next to any particular number, that number's crossed out, doesn't count. And you keep filling in this table with all the students' name, and then whichever number remains with only one student's name next to it, those are the numbers that are still in the competition, and whoever's got the smallest one of those numbers is the winner. I'm sure I've made that sound more complicated than it really is. Anyway, all the instructions are on the page, but it's great fun, and it's something that the students will really struggle to try and figure out a strategy of how to choose the number that they're going to pick. Do they pick 1 and 2, or are those too obvious and other students will have picked them? So where exactly do they choose their number? So the questions that go with this game after it's finished are, what number would you choose if you were playing the game, obviously? Are there any winning strategies? And what is the probability of each of the numbers being the winning number? This suddenly strikes me as being a good IB internal assessment exploration. A lot of data could be collected from lots of different classes playing this game. Which numbers are chosen most frequently? Anyway, I'm sure you can take that if you're interested. I am grateful to Transum friend Anne, who alerted me to breakthroughs in aperiodic tiling.
Mathematicians have recently discovered a 13-sided shape nicknamed the hat, which is a significant breakthrough in geometry. It represents the first true example of an Einstein, a term derived from the German word for one stone that refers to a single shape capable of forming a unique tiling of a plane. For nearly half a century, mathematicians have been searching for such a shape. The tiles of the hat fit together seamlessly and can cover an infinite plane, but they are aperiodic, meaning they do not form a repeating pattern.
Wow, it all makes tessellations look very pedestrian now, doesn't it? After struggling for years to fill the plane with a repeating pattern, now the challenge was to fill the plane with a non-repeating pattern, and they've just done it. So that's amazing that mathematical discoveries are still being made in this day and age. Well, of course they are, but ones that we could sort of almost understand. So that's all over the web and all over YouTube. So if you're interested, look up aperiodic tiling. Finally, the answer to last month's puzzle, which was about making 100 from 4 sevens and a 0. My answer is 77 divided by 0.77. making use of the decimal point. Haha, did you think about that? And other answers were very similar, such as Martin's, which was 7 divided by 7, multiplied by, and then I think we better put this in brackets, 7 divided by 0.07. That was Martin's answer. So all quite similar, but yes, it is possible. And that was to celebrate the 100th episode of this podcast, which we now passed because this is the 101st. Anyway, I hope you have a good April. I'll be back again in May. Bye.
Thank you for downloading and listening to the Transum podcast. You can find the website at www.transum.org, where you're welcome to use all of the activities absolutely free, or jump in with both feet and become a Transum subscriber.